Yes. Hello, everybody, and welcome to the number one generative AI podcast in the world with your hosts, Mark and Shashank. That's us. So, anyways, uh, you guys are awesome. So, the podcast has actually been growing. Um, so if you're new, thank you for listening. If you have been listening, thank you for listening. We really appreciate you. We recently we've seen a big uptick in listeners, so I hope you guys find this interesting. We've been trying to really post the video podcasts lately, but yeah, it's a bit of a slow news week this week. Um, yeah, uh, but there still is a few things to talk about. So, Shashank, did you hear that TSMC is now producing 4 nanometer chips in Arizona?
That's pretty cool. I know they were talking about that for a while. I know, what was it like, Foxconn tried to come into the US, but that never panned out. Hopefully this actually pans out. I think Trump is really trying to push domestic manufacturing, so maybe some good can come out of the new presidency and have, the entire, well, more of the supply chain for hardware built in the same country, which de-risks um, all of these companies because, TSMC is kind of in a delicate situation right next to China. And not to mention just having one single company in one single country be responsible for so much of the world's technology is just kind of a risky situation to be in.
Yeah, for sure. I feel like if you were gonna write a novel about how to take over the world, I would definitely write, like, the sci-fi novel, just put Taiwan right there in between all the superpowers, kind of a little bit defenseless, and, yeah, it would make for a really interesting, book, but yeah, I think that basically, yeah, as you mentioned, the problem that the US has is even though we design a lot of chips in the United States, right? I mean, like Apple, I think it designed some of its own chips. You have NVIDIA, I think Qualcomm does a lot of the chip design, Intel, all these companies.
AMD,
Yeah,
so many companies.
basically all the companies, they design their chips in the United States. Even the AI specific ones like, Cerebras and Samba Nova and Grok, they're all designing their chips in the United States. But pretty much all of them will use TSMC, to develop the chips, right? So
Manufacture it.
yeah, to manufacture the chips. So, like, TSMC is just, uh, they're not designing the chips, but they're actually gonna be the ones who make it, and that's part of the reason why we see on the back of the iPhone, what is it, like, "Designed in California, made in China?" Um,
I don't think they put the made in China part. They leave that out. But yes, designed in California.
yeah, exactly, but, it's basically made in China, right? And, so anyways, with that being said, right, I think that the fact that the TSMC is moving some of their actual manufacturing efforts to the United States is gonna be huge for just, like, national security and helping the US stay on top of the generative AI movement in general, right? Um, although I was reading that apparently, you can't do all of it in the United States. So apparently,
Hmm.
some of the final steps, I think it's the packaging, needs to be done in Taiwan. So apparently,
Oh,
they do some of the chip manufacturing in the US, then they ship it back to Taiwan for the final packaging, which doesn't exactly make sense to me,
yeah.
from the article, but maybe there's some really fancy packaging that they need to do, put the big bow on the box or something, right? And then they can ship it back, but apparently that's coming, and apparently, soon, they're gonna have some of the smallest and best chips in the United States, so maybe soon the iPhone will say, "Designed in California, made in America."
Well, I mean, just to clarify that point a little bit, Foxconn is still staying in China, so it's still gonna be a made in China phone. But at the very least, if you look at the CPU and GPU and the processors, that at the very least might be entirely made in America. But yeah, that is a kind of a weird, caveat that it's gonna be mostly made here, but then sent back before being sent again back to the US.
Yeah,
Or maybe it just goes, to China from Taiwan from there, because most of the stuff is assembled in China at Foxconn or somewhere else.
yeah, but Foxconn, I think, has some factories in the United States.
Okay.
So, for example, Lordstown Motors? That was like the electric
EV? Yeah.
the electric car company. They're, I think, either in Ohio or Pennsylvania.
Okay.
I remember I was driving to Pennsylvania. Actually, I was driving to Titusville, Pennsylvania, maybe a year ago. So Titusville, Pennsylvania, as an aside, is super interesting. So, it's not exactly related to Gen AI, but we can try to make the parallel. So, basically, Titusville, Pennsylvania is the start of the oil industry in the world, basically. So, for those who don't know, there used to be pretty much only one oil company on Earth. That was Standard Oil, and Standard Oil was owned by John D. Rockefeller, who is arguably the richest guy in all of history.
Mr. Oil, yeah,
Yeah,
Standard Oil.
he made a lot of money, and
He's the reason we have, antitrust, laws to break up massive companies.
exactly. So, super big. And if you actually kinda trace back all of the biggest oil companies today, like, I think BP and Chevron and
Exxon,
Exxon and all
yeah.
these super massive companies, they all used to be one company, and that was Standard Oil. So, yeah, he was a billionaire back when a billionaire actually was a lot of money.
That was a lot.
That was a lot of money.
That was a lot of money back then.
Yeah. I mean, it's still a lot of money today,
It's still a lot.
but, 200 years or like 150 years ago, I don't
Who's like
know,
the Elon Musk of the day?
but, like, more so almost.
The Elon Bezos of the day.
Yeah. Yeah, exactly. So, yeah, Titusville, Pennsylvania was where they started drilling for oil in the United States, and it was kind of the thing that, put him on the map. Also,
Mm,
he actually never drilled for the oil. He did the
mm.
refining of the oil. So they would use trains or use pipelines to bring the oil back to Cleveland. And then in Cleveland, Ohio, is where he would have a lot of his manufacturing and like processing of the oil, where they turn it into like gasoline and whatnot. So generative AI maybe is the gasoline of the future. Does that work?
Maybe, kind of. I guess, it is the currency, it is the gold, the liquid oil of the future. But speaking of, like, oil and energy, I feel like, we need to start thinking about more and more energy to fuel all these different models, 'cause, um, all these companies are building, massive plants, and, yeah, I think, the TSMC plant will be pretty cool, but we're gonna need, like, a lot of energy to fuel all this stuff.
Yeah, for sure. We will. Because I think when we were talking to Matt from Cerebras, he was mentioning that I think one of their nodes used like 20 kilowatts of power. I think that's what it was.
That's like a one wafer
Yeah, just one wafer.
in packaged up into a solution with networking and
Right,
stuff.
exactly. And in order to train a big model,
Yeah.
or even to run, I think Llama 405B,
Mm,
um, which is, Facebook's new LLM, uh, you would need maybe a couple wafers, I think,
mm.
in order to run it, right? So, since it's the video, we should bring over the wafer for
Go for it.
effect. One moment.
So this is not gonna be an actual wafer from any of the companies that we talked about. This is a long defunct wafer that I got from someone here nearby. He used to work at SanDisk, so it's a memory chip company, and this is a die of a bunch of memory chips from SanDisk. It's probably a defective one they had to throw out for some reason, but if you look at the video, you can see a bunch of symmetrical little cubes. They're all identical uh, memory chips that'll go into maybe like a USB stick or something.
Yeah, so you'd have something like this, right? But Cerebras is interesting because it has the entire um, it uses the entire wafer, right? So typically what will happen is companies like NVIDIA or AMD, whatever, they will go and then they will actually make multiple CPUs. So they'll go and then cut out just like a small piece of the wafer, essentially, and then they'll use that for their chip. But Cerebrus, they will use the biggest possible square from the wafer. And since it's so big, it uses a ton of power, which is like 20 kilowatts. And I think that, what is it? A house is maybe, well, like a small house is maybe like 2 kilowatts or something like
Right.
that. And then like probably like a medium to like large size house is like 10,
Yeah.
10 kilowatts. So uh like 20 kilowatts is like a big house.
It's a lot of power.
Yeah, that you would need. So if you need a couple of those, I mean, that's like that's a lot of power.
That's like a lot of power for one node, which I assume maybe can handle a lot of queries, but still.
Yeah. I mean, sure, it's really fast and everything, so that's nice, but it's just, you know, um, not that efficient, and
Also, since we have the chip right there,
yeah,
it was kind of interesting that Cerebrus figured out a way to handle the issue with um, having defective nodes in the middle. So usually, like when NVIDIA makes a chip like makes uses a wafer like this, they'll
so
have
for the listeners, we're looking at basically just like a Frisbee. It's about the size of a large dinner plate maybe,
yeah.
and there is a bunch of squares on the chip. So imagine a dinner plate with like a checkerboard kind of on it.
Yeah. So if you look at the checkerboard, we have these really advanced machines from ASML that go in and etch all these little circuits, these intricate patterns inside each checkered pattern. But not every single cube is going to be perfect. There's going to be a lot of defects. So NVIDIA has to deal with this problem of yield. So this one wafer might have a yield of, I don't know, I'm throwing out random numbers here, 90%. The other one might have 80%. The other one might have like 70.
So I guess if we put that into words, right? If there are, I don't know, I can't
Let's say
count it,
10
but there, let's say that, yeah. So
or 100.
if there's 100 of these individual processors or memory units on this chip that you cut out,
In NVIDIA's case, there would be GPU
G
units.
GPU units, then if there was 100, then if you had a 90% yield, that would mean 10 of them are just defective. You just need to throw them away, try again.
Yeah. So they would kind of like block out those sections, those defective units, I assume through software. And the funny thing I just kind of like realized a few weeks ago was that's the reason why they have different SKUs of their consumer or like all the grades of GPUs that they market. So the consumer grade GPU, the RTX 4090 used to be like the best GPU that you could buy. Um, this year at CES, they released their new series, the RTX 50 series. So it's like the 5090, 5080, 70, so on. And the 5090, the top of the line GPU, is just the one with the highest yield. Apart from a lot of other enhancements, it has like more memory, more clock speed and whatnot. But one of the things that distinguishes all of these different SKUs, all of these different models, is just that they have better yields. So like the whole GPU just has a lot of functioning parts. And the ones that don't have a very good yield, the ones that have a lot of defective units, they're not going to throw like the whole GPU away, even though a little bits and pieces of the sections inside may not be working. They just turn those off and sell it as a lower performing GPU.
Although it's not, that's not the only
That's not
difference,
the only
right?
thing. There's differences in the amount of memory that it has, the amount of clock speed, and presumably other things. But this is one of the things that differentiates the different SKUs.
So if I have the new fancy NVIDIA 5070,
5090, the
well,
highest.
I guess so what you're saying is like the 5090 would have the lowest or the highest yield,
Yeah,
maybe 90% yield
yeah, almost perfect. No,
ish,
virtually no defects.
right? I don't know. And then let's say I had the 50/70, and maybe it's only a 70% yields. And I'm sure it probably doesn't map one to one like
Right,
that,
right.
but that might be a thing to think about.
Yeah.
And then say, okay, we're gonna take this lower yielding chip because it's the same chip maybe as like the 5090. We're gonna take the lower one and then we're gonna slap some extra memory on there, maybe a little bit more cooling, give it a little bit more power, whatever it needs, and then sell that as a different chip. But I mean, that's kind of smart,
Yeah,
good
yeah.
economies of scale.
But the thing about Cerebras is because they can't just chop up this entire wafer into maybe like dozens of different GPUs. They have to figure out how to deal with these defective pieces in the middle of their gigantic integrated circuit. So they come up with a lot of interesting rerouting algorithms to send information around the defective parts, which no other company, as far as I know, seems to be doing.
Yeah, it's super interesting
Yeah.
how they do that. Um, anyways, you remember last week when we were talking about, just to switch the topic, do you remember last week when we were talking about how robots will need some sort of way to get data from
Self-play.
that through like the real world or self-play or something? Because, I had that whole thing where I think that the LLMs are gonna kinda peak around 100% of a human, maybe like 110, 120, but they're
Mm,
never gonna like far surpass humans,
mm,
right? So there was a paper that came out a little while ago. It actually came out in January 2024 is when it was first submitted, but I heard about it like, well, last week when you said it to me. But apparently there's this team out of I think they're out of China, and they are making this Python framework called GEXP. And that framework, what it does is it kind of does what we're talking about. So I dub it so baby robot.
Okay.
uh, now, the textual paper name is "Growing from Exploration: A Self-Exploring Framework for Robots Based on Foundation Models,"
Mm.
which is really a nice name.
Classic research paper name.
Yes, but I like baby robots. So basically, what it is, it's a framework where it will have essentially a robot in either a physical environment or a simulated environment, and it'll just go and try to um, noodle around and try stuff. And you can give it individual tasks to create stuff. And then essentially, that could be a way to get unlimited training data.
Mhm.
So I think that this will be the way, or something like this, is maybe going to be the way that we're able to kind of break through that training data problem. So I would imagine that there could be either a couple things. Um, and maybe it won't be necessarily this framework, but I could imagine in the near future, we could have robots, maybe millions of robots, billions of robots, all running scientific experiments and just trying stuff, right? So I would imagine maybe they'll just go and just start mixing chemicals together and seeing what happens.
That's so, uh, I'm really fascinated by this, topic 'cause, I started subscribing to this new thing called Journal Club where they send you a new interesting journal every week, and this was a topic for last week, and, I I think about it like trying to get a robot to learn a specific task. So the most popular area is self-driving, for like quote unquote robotics, physical robots, physical machines that move and do things in the real world. So for self-driving, they've been collecting a lot of driving data through different approaches. Each company is trying to do it differently, but essentially they're all just collecting as much data about driving as they can. And there's kind of a limit to how much data you can collect because um, most people go on the same roads within a certain country, city, whatever. And then once you've mapped all of that data, you're kind of out. So once that environment changes, if like we start seeing forest fires, massive, massive forest fires that are unprecedented, or like massive hurricanes that flood the entire street. It's like, what do you do in that situation? Or, someone decides to go off-road a little bit, or a tree falls in the middle of the road, which are all these long tail scenarios that don't really happen that often in the real world. It's kind of hard for these models to know what to do with things that haven't happened yet. So that's where you get this kind of ties into NVIDIA's announcement with the Cosmos real world simulator. So it can create new kinds of environments and allow these robots to go and explore this new environment to collect data for themselves. So I guess another example is if you wanted to do some basic chores around the house, have it fold laundry, you can just have it go and throw it to a bunch of virtual clothes and have it figured out itself. Just give it a reward function. Tell it that this is what a folded pile of clothes looks like, and just keep hammering at it until you figure it out.
So would the reward function be maybe you just say, "Hey, this is what I want the clothes to end up like."
Yeah.
So you just say, "Hey, this is the clothes we've got,
Yeah.
and then here's where I want them. Like here's them put away
This is
nicely
the
in the closet."
configuration that I would like it in.
Yeah, so just do that, then also avoid damaging things. If maybe
Right,
like you
right.
could say like if you hit a wall or something, then that's like negative points.
Bunch of safeguards. Don't make a mess. Don't hurt yourself. Don't hurt other people. Don't break anything. Try to be efficient. Don't rip the clothes. Some safeguards, but you don't actually tell it how to fold the clothes. It'll just go and figure it out.
Yeah. I mean, I feel like you could use that technique for pretty much everything.
Yeah,
Laundry, dishes, gardening,
yeah. 'Cause what
chemistry.
what is the alternative? You get a human in maybe like a motion capture suit, or record them with a high fidelity 3D camera, which captures their pose and maps that onto a robot for training data. But then it's kind of hard to scale. Physical humans uh, take a long time and they run at 1x speed. Like I can't operate at 2x speed. I can listen to maybe YouTube videos at 2x speed, but even that's a stretch. But with these virtual environments, you can have these robots operating at however fast the GPU will allow them to run. You can run them at, I don't know, you can get them to learn tens of thousands of regular real world hours within a couple hours. So I think the ability to scale, um, the the ability to have them learn by themselves, cover the long tail of edge cases. Um, yeah, it's gonna be fantastic. But
Yeah. Have you ever read The Bitter Lesson by Richard Sutton?
no, what's that?
Yeah, so it's a really short essay, and it basically kind of describes what you mentioned. So it was written, actually, I don't know when it was written, but it, it's really an interesting uh, thought. So it argues that general purpose solutions will
Mhm.
always win, essentially.
Hmm.
So um,
What was the context?
well, it's more of kind of an overarching thing in AI research
Mhm.
where apparently, like Waymo, when they originally tried to develop self-driving cars, they would try to solve every little last piece part
Right.
of the self-driving situations. Like,
I
oh,
remember they were focusing on geofencing. They were like, only within the city limits of Phoenix is this gonna work.
right, but not just that, but it was like, oh, let's have a guy who just hard codes what cones look like. So we have
Mm,
a cone guy,
mm.
right? So it'll be like, "Oh, this is a pointy cone and it's orange and this one's green," and you just have it know what all the cones look like. Or as opposed to teaching the car all about the cones, what another alternative you could do is just have it mimic the way a human drives in a bunch of different scenarios, and then just train the neural network on that. So as
Mm.
opposed to trying to say, "Hey, let's go and figure out all the different combinations of the way the car could drive.
Hmm.
You just try to mimic what a human does, and then it'll just kind of infer what to do based off the environment. Now, I'm sure they maybe have a lot of other safeguards because I mean they are only geofenced to a particular area, so I'm
Hmm.
sure they have super detailed maps and whatnot. But at the end of the day, my understanding is that they use more of a general purpose solution for their self-driving cars as opposed to trying to go in and just say like, okay, this is what we do on a red light. This is what we do. I mean, maybe you have the red light, green light type thing, but it's not just like, hey, uh, let's hard code in all these rules. It's
Hmm.
more general purpose than that.
Yeah, that's really exciting to think about, not just with robotics, but if you expand it just to regular LLMs too. Why does the process of training, deployment, and using a regular LLM have to be limited with, you get training data, you pre-train it, do some reinforcement learning, and then use it? Why can't it just keep exploring itself and acquire skills, learn about the real world, build its own internal knowledge, and then keep getting better?
Yeah, I mean, I think that will be the approach for us to reach AGI.
So, this particular paper that we talked about, it breaks down its process into a couple different steps. One is, so this is specifically for robots and the real world. So it uses vision language models, VLMs, and it breaks down its process into task one is perception and task generation module. So it uses the vision language model to figure out where it is, what's going on, and what is the high level objective that it needs to do. Then it breaks down that objective into a bunch of high level tasks. And then the next step is it takes into planning and execution module. So it figures out from the high level tasks, how do I break this down into individual subtasks? And then, given its set of skills, what ability that robot has, and what it's been trained on, start executing each of those subtasks. And then at the very end, it has like a uh, verification and error correction module. So it just makes sure that the things it's doing is doing it right and nothing crazy is happening. And the very last step is like reflect on what it's done, all the little experiments that it's taken along the way, and see if there are new skills that it can incorporate. So I feel like we can incorporate this into like an LLM too. And as opposed to having uh, application builders use LangChain and hard code a bunch of different skills and agentic behavior, just have this run wild. Maybe have it observe your behavior and learn by itself.
I feel like it needs a different name because that sounds more than an LLM, right? Because if an LLM is just taking text input and
Mhm.
then trying to figure out the next token, that makes the most sense, right?
Mhm.
Because that's basically an LLM. It's just like, the large language model from ChatGPT, it just says, "Okay, based off of this, all the everything that I know that comes before it, here's the next best word, or the next best token." It'll do that, right? But this, it feels like it's not just like words or tokens, but it's more than that, right? Because it takes in a vision, and maybe they can all be
Doesn't
boiled,
have to be vision, but yeah.
but it takes in more that I mean, maybe it'll all boil down to tokens,
Mhm.
but, um, it's not, like, really like a language model anymore. It's like a like you could have, like, a large world model, but,
Sure.
something like that, or like a like a reality model or something?
Potentially, yeah. But no, I was thinking even within the constraints of just a purely text model,
Yeah.
like um, even the O3 models, like the reasoning models, they're kind of cool, but it's still somewhat limited. So if there are things that it's just cannot do,
Yeah, so,
maybe
but by the way, the O3 model is the most advanced model that hasn't even been released yet
no.
from OpenAI. So we were talking about it a couple episodes ago. It did really well. So it is a basically a chat GPT that is able to reason and think for itself. So as opposed to doing just one singular output, it will go and then think about what it's going to respond. And it might think for a while and then give a response back. So that this kind of self-reflection that it's able to do and maybe simulate out a bunch of different answers turns out to be really effective. So it's basically it's like as opposed to just giving one response, it might give a million responses all at once and then figure out which response is the best, maybe by having some sort of self-reflection. Um, and that's the O3 model. So anyways, continue.
Yeah. Wait, what was I saying? Oh yeah. So I think to to get like the OT model to solve any kind of task, even when it hits a roadblock, I think it would be cool to give these models the ability to learn and update their weights in like a live real-time training environment. So when I was listening to the ArcAGI challenge and Francois Cholet, the
But by the way, yeah, ArcAGI is a benchmark, which is kind of like an IQ test for the LLMs.
Yeah, so, it was an IQ test, created, maybe, like, last year because, the creator of that test, realized that all of the traditional benchmarks that we had kind of had limitations, and they were all being gamified, and anytime you create a benchmark, it kinda like you get something that just beats it, maybe through brute force, maybe through, like, hacking it, finding loopholes, whatever. So, he just wanted to create, like, a solid thorough benchmark that could encapsulate what it means to be intelligent. And this is a constant work in progress. This is by no means like a job that's done. They'll constantly keep making the next iteration of their AGI test. But this test was like a spatial IQ test where you had certain patterns of images that lead from one sequence into another. And then you see a new pattern and you have to match the start to the end. So, um, one of the theories that Francois Cholet, the creator of this prize, mentioned was that he's starting to see these models have some kind of like live training process where each example that it sees while it's taking the test, uh, that example is being stored in memory, is being used to fine tune that model so that the next answer that it gives is using all the learnings from all the previous examples that it's seen. So maybe if you had a model that is always learning, it's not fixed in that specific snapshot that you get from that API. Maybe it's running locally, or maybe it's using some kind of a persistent memory or something, like the memory feature that ChatGPT has from OpenAI. And if it's constantly learning and it has the freedom to maybe explore a little bit, try different things, and like you mentioned, spin off like a million different versions of itself, maybe more realistically, dozen different versions of itself, and see which version of itself has some interesting intuitions, and then go deeper in that tangent.
Well, I don't know. I think that it may be depending on the type of problem that we're looking for, it might be a billion iterations
That's
that
true.
it's looking at,
That's
right?
true.
So a little bit of story time. I have a perpetually kind of stuffy nose. I've been working on it, and I've been trying to figure out, why is it stuffy so much? And I've gone to the doctor, and I just got a CT scan of my sinuses yesterday, and I was trying to figure out, what does the CT scan mean, right? So, because thanks American healthcare system, I wasn't able to get an ear, nose, and throat person to look at this. Well, I mean, I could probably find another radiologist or something to maybe look at it, but I really want like the ear, nose, and throat person to look at it and tell me what's wrong. And I was like, all right, let me just try this, and I gave the images to the Claude 3.5 sonnet,
Hmm.
and I had it interpret the images, and it seemed pretty good. Now, I'm not a radiologist, so I don't I can't vouch for how good the interpretation was, but it knew from the image that it was looking at my sinuses. It said, "Oh, it looks like you have a slight deviated septum,"
Hmm.
which apparently means like your nose is like a little bit crooked. So like one nostril is
Wait, let me see.
yeah. Can you see can you see it? Yes, on the video version, Shashank is looking at my nose, but yeah,
Is it leaning to your left a little bit?
yeah. Apparently, it's leaning in one way a little bit,
Ah, I can
and
see that.
a little bit, yeah. So maybe it needs to be straightened out a bit. And I also use if you guys have a hard time breathing, these breathe right strips are really awesome. So there are things that can kind of like pull open the nostrils a little bit and help you breathe a little bit easier. And then it also said, "Oh, I noticed a little bit of uh, gray in the image because so it's like, well, I don't know have enough image, but apparently, like gray can indicate like some mucus buildup
Hmm.
or some additional inflammation in the nose. So with that being said, it said like, yeah, it looks like this could be due to all of these different reasons, and um, but obviously check with your ENT. I was like, well, I can't talk to them until March, so Claude, you are the next best thing.
Huh.
So I said, "Hey, my plan is to go and then use Flonase and then also use talk to an allergy doctor to see if I can try to figure out solve the allergies because apparently one of the big causes for inflammation is when you have allergies, the allergy like you have like the buildup of pollen or whatever. Your body has an allergic reaction that has inflammation of the nose, and then it's harder to breathe.
Hmm.
And then if that happens enough, you get nasal polyps, which I kind of think of are sort of like a nose acne on the inside,
Hmm.
and then they make it harder to breathe. So oftentimes, what your nose and throat doctor will do is they'll do this surgery where they kind of like cut all the polyps out.
Hmm.
But what they'll typically do is they'll say, "Hey, why don't you take something like Flonase, which is like a steroid for your nose, which you
Hmm.
just get like at Walgreens or something, and then you put it in there, and then the nose will start to um, kind of like eventually shrink the polyps,
Hmm.
or like kind of like lower the inflammation. And then if you could do a double whammy by going to your allergy doctor and then by starting to do the thing where you reduce the allergies. So apparently what they have now is they have these allergy drops. What you can do is like you do like a daily drop
Hmm.
of the thing that you're allergic to, and then that's actually a lot safer than actually getting the injections for because apparently
Like a vaccine?
no. So apparently, in order to combat allergies, what a lot of times that they've done in the past is the gold standard for allergies is to do a skin test where they will it's called a prick test where they will have maybe 50 things that you might be allergic to, and then they'll just kind of give a little, of that thing that you're allergic to, put it on your arm or your back or your
Hmm.
shoulder or something, and then if it kinda swells up, then they're like, "Oh, you're allergic to that." So then in order to, kind of fix that, what they used to do in the past is you would go to the allergy doctor, and then they would just give you in larger and larger doses the thing that you're allergic to. So they would start, like, really small, and then they would just kind of like, every week or every couple weeks, you'd go, and then they just, like, give you, like, little slightly larger doses.
So you can build up the immunity to that?
Exactly, so you build
So
up
it's
immunity.
essentially like a vaccine.
Uh, yeah, kind
Yeah.
of, yeah.
Give
Uh,
you the thing that you can't, fight off in larger and larger doses, so your body learns how to
e
fight it itself.
exactly, but, that's a big hassle to have to go to the allergy doctor every time, so apparently what they start having is they call these, like, sublingual drops, which is just
Mm.
like, like an eyedropper type thing of the thing that you're allergic to. You put, like, 1 drop under your tongue, and then you just do that every day. You do that for a few years,
Mm.
and then you don't have to go to the doctor.
For a few years.
Well, yeah, I mean, because apparently if you do the thing for the allergy doctor, that takes a few years as well. They do
Oh,
once a week.
okay.
So, I mean, it's just kind of like one extra thing that you would do in order to help with the allergies. So anyways, bringing this back, right? I think that these types of things, um, a doctor is gonna be able to interpret it, right? But I think that over time, what will happen is you will have the AIs
Mhm.
trying to do the experiments on maybe simulated environments
Yeah.
of humans,
Mhm.
or maybe you would have the AIs running experiments and I don't know, maybe looking at cadavers and cutting up bodies and figuring out what how things connect to each other, and
Mm.
they might have a much better understanding about what's going on in our bodies. So then maybe in the future, we won't be asking the doctor. And honestly, even right now, I'm not asking the doctor. I'm asking Claude because it's available and it could give me an answer that I'm looking for. As opposed to needing to wait until March. So for reference, it's January, so they said, "Oh, yeah, we can't get you in until March," which is ridiculous.
This is nuts. It's really like some Black Mirror type alternative reality. Like 2 years ago, if you'd have told me just give this website your CT scan and it's just gonna tell you exactly what's wrong with you, that is nuts.
Yeah, so I here am ready for it, and let's bring on the robot doctors.
Well, what
Let's
but to pump the brakes a little bit, we all know that these LMs have a remarkable ability to hallucinate, so it could just be pulling out of all of this, out of its rear end, and we would have no idea. So, Mark is not a medical professional, and we would definitely need to fact check all of this before, making any major decisions.
Well, so to be fair, and actually to back up what I've learned, there was a I actually did go to a doctor, not about this because I just got the CT scans today, but I was doing some research. So both on me and then also for some friends and whatnot who were asking me for advice. And I did a little bit of research on uh, ChatGPT or Anthropic, and then I went to the doctor, and I was able to diagnose some really obscure things. And he's like,
Huh.
"Wow, you really did some good research."
The doctor did?
Yeah, the doctor,
Wow.
so, there was like a thing, I don't wanna get into it, but, there was something on, like, somebody's, like, gallbladder,
Oh, wow.
and I didn't even know what a gallbladder was, but, somebody said, like, "Yeah, I have, like, pain in my, like, upper right-hand
Does it
shoulder."
secrete bile?
Yeah, it
It helps
does.
you digest stuff in your stomach?
Exactly,
Okay.
exactly. So, it's, like, the thing that
Pulling out my high school biology.
because and apparently, if you have, like, some pain in your upper right-hand shoulder that
Yeah.
doesn't go away after, like, you kind of move your shoulder around, that could mean that you have gallbladder pain, and that might mean that you have, some bile that is, like, stuck in your gallbladder, and that oftentimes that can come from, like, eating maybe, like, fatty foods
Mhm.
or something, have a little inflammation there,
Mm.
so apparently, there is some surgery to, help with that, but, who wants to do surgery? So, what you could hypothetically do is you could just eat better, and then that might, like, help reduce the inflammation, and then, because what you don't want is that they have these things called, like, gallstones, and
Mhm.
then, like, the gallstones get stuck in there,
Yeah.
and then it's just super painful.
Yeah.
So, I figured out that somebody had, some, like, gallbladder issues,
Huh.
and then,
Like, 'cause of a shoulder pain that they had?
yes.
No pain? That is insanity.
Exactly, and
Okay.
it wasn't me that figured it out,
Yeah.
it was the AI.
Wow.
So, or
Good
the
times.
and the doctor is like, "Oh, yeah, wow, I don't know how you figured that out." But here's the thing, I didn't. Uh, so, I say bring on the AI doctors, and then we'll just have the human doctor just make sure we don't kill ourselves.
That sounds like a good, caveat to put right at the end. But, yeah, I mean, I honestly, I use AI for, uh as like a first step for any kind of issue that I face, medical, non-medical, technical, emotional, socio, interpersonal, whatever it may be. So not a bad approach.
Yeah. So, anyways, I think we're about out of time,
Yeah.
but this was a good conversation. And guys, we'll catch you in the next one. But before you go, one announcement. Uh, Next week, so a week from today, on January 23rd, 2025, depending on when you're listening to this, in Palo Alto, California, there will be an event with Sentient AI. We mentioned it last time, but Sentient is doing some really cool stuff. They are building community driven LLMs and machine learning. So they're trying to find a way to make it so that it's not just going to be the big boys that can make the models, but maybe together as a community, we will be able to make LLMs. So they're going to be giving a presentation. They're going to have a handful of the folks from their company there to present and talk and just chat with you guys. So there aren't very many spots left. I think there are maybe like 30-ish spots left, 30 something spots left. So if you're interested, make sure you RSVP because that's it. I mean, it's free. There'll be like food and stuff there, but yeah, the space is limited, so we can't fit that many more people. So if you're interested, sign up because yeah, the space is running out. So yeah, we'll leave the
And
link there.
it'll be a great opportunity to network, meet other people working on in this space, way smarter than the both of us. We have some of the smartest people from Silicon Valley, engineers, execs, VPs, CTOs of massive, very fascinating projects that these people are working on. So definitely come check it out, and you'll definitely learn something.
Yeah, awesome. So we'll catch you in the next one.